Okay, this is where we left off with last week. Okay. We did already. Whenever, what works best for you. Okay. All right. What can you tell me about an alkali metal? That was one of your vocab terms. Column 1. So what does that tell you? One valence electron. Okay. What about alkaline earth metal? That's what? Give me an example of an alkaline earth metal. What? Yes. We did, but we're still reviewing. Calcium is one because it's in column 2. Okay, now, elements in group 2 all have 2 valence electrons. Okay? So, boron family, what column is that in? Third column. Carbon family. Do we see, again, this pattern that arises? Whatever column it falls into, S block and P block, that tells you how many valence electrons there is. Okay? So can someone give me an example of a halogen? Don't say the column.
Krypton. Fluorine.
No.
Fluorine.
Fluorine is one.
Fluorine.
All elements in column 7 are halogens. Okay? So, since it's in the 7th column, how many valence electrons does it have? It's got 7. Okay? So, therefore, its next door neighbor, which some of you probably utilized as the noble gas configuration, what does that tell you? Its outer energy level is what? Its outer energy level is what? No. It's full. It's got 8 valence electrons in it. Okay? That's what we're talking about here. Elements in column 8. Helium only has 2. That's an exception to the rule. The rest have 8. Okay? Does that make sense? Okay? So what we have left to go over is just that. Okay? Well, that was from a previous edition. Does everyone have this information that wants it? Okay? Okay, how about now? Okay. So, as we continue, is anyone having problems with noble gas configurations or Bohr models or anything to that effect? We're good? Okay. I'm going to shut this off now. So this is what I want you to do. If you get your table out, okay, pick an element between 91 and 99. 92. Okay? 92 is uranium. Okay? So if we're going to do element 92, and 238 I believe. Okay. Yes. With everything that we've learned so far, was everything you can tell me about uranium?
Its protons are 92.
Okay, it's got 92 protons. Why are you right?
Because its atomic number is always.
There's this atomic number. It's neutral.
238 minus 92.
No.
92.
92.
Oh, you just mixed it around, man.
So how many neutrons? How would you calculate how many neutrons it has?
38 minus
92 take away, 238 take away 92.
And that gives you what?
146.
146. Okay. Now, if you were to do, take your cap off.
Come on, super puncher. He's a super puncher.
This is what we're worried about up here. Okay? All right. How would you start your noble gas configuration with this? Do we go up or down?
Well, technically down, but up.
Right. So what noble gas would you want?
Right on.
Okay. So once you do that, we're already up to what element or what number? 86. Now, you could use xenon, you could use krypton, you could use any one of the noble gases, but the close, it's going to be more work yet. Okay, what period is radon in? What block is radon in? And what column in the P block is radon in? So 6, P6 is full. That's what you could take from that, right? Okay, so you're right, but how did you know that, though? When you say the next one, what do you mean by that, though? The slide rule. So you correctly said 7s2. What comes after 7s2? Now, what column in the F block only is uranium in? Okay, let's go ahead and take a look at that. Okay, that would be right. 4 plus 2 plus 86 gives you what?
92.
So that's got to be right then. Now, for those of you, when you look at lutetium or the rhenium, what block is that in? Because it's on the bottom here. Okay? But those two elements on the very end, what block are they in? The D block. Because this is where your F block starts. Okay? That makes sense. Okay? Now, do you want to do the Bohr model for this? Okay? How about, let's do the Bohr model for, how about polonium, 84. Okay? Let's go ahead and attempt that. Okay, so what is everything you can tell me about polonium?
84 protons.
We'll just put 84 in here. Okay? Now, is this an S or a P block element?
This would have to be a P block.
It is. So can you make predictions for that?
You can make it, like a 3 number.
Right. Okay, so what period is polonium in?
6.
Okay? What column in the P block only is polonium in?
4.
Okay? And then of the entire energy level, what column is polonium in? Of the 6th period, 6?
Yeah.
Okay, I'll take your word for it. Okay, so these 3 numbers we're going to see again.
Wait, how'd you get the first number?
It's in the 6th period.
How'd you get the last 6?
Because that's what column it is in the entire period.
Yeah.
Okay? Does that make sense? We'll see them here shortly. Okay. Follow your slide rule now. What are we going to put here?
I'm gonna throw a 2 in there.
Then what?
2, 6.
Oh, this, then this. Okay? So now, let's count our energy levels. 1, 2, 3, 4, 5, 6. There's that 6. Okay? Then, what column in the P block only is polonium in? Okay? Okay. So, as we count, so here, 3, 4, 5, 6, there's that 6. 4, there's that 4, and 2 and 4 gives you 6. That's where that 6 came from. So you can make those types of predictions. Okay. If we add all these, has someone added them together? You do get 84? Okay. But this doesn't work for all elements. Okay? For those of you, when you move further ahead into chemistry, if you're working with D block elements, you can make those predictions. But I would suggest you don't do that yet.
I didn't get 80.
1, 2, 3, 4, 5, 6. There's 12. 1, 2, 3, 4. 24. 10, 20, 34. You got 74. Okay?
We have to add that 10. You have to add the 10 before you add the 10.
Okay. Now you got 84?
There we go.
Okay. All right. Any questions? Okay. Now, you have that opportunity to go back and watch this. It's entirely up to yourselves. All right. We'll catch up to you next time.